project, and during the process we will need to run two tools. We need to process using two tools. The first one is called bunch. This one is used for do the clustering of the packages, and when we have the result of the clustering, which is modules, and then we feed it into a tool called module. Module is used to compare two architectures of the application.
Okay, so it's pronounced as mojo, move and join combined together. So it's mojo. So what it does is that it takes the module returned by bunch and actual ground truth. Ground truth is actually the real architecture of the application. So it will compare and say how much accurate the architecture recovered by bunch is. So it's a measure of accuracy. So mojo is a measure of accuracy. So its range is between 0 to 100. 100 is maximum, like if you get 100% accurate clusters, then you can say bunch recovered the perfect architecture of the application. And 0 means the other end, so very incorrect decomposition of the application. So that's the accuracy measure. So the pipeline is like this. First you take the application, and the first task is to estimate the similarity between the packages. So that's the first task. So the similarity between a package will be a matrix, like package 1 to package 2, what is the similarity? Package 1 to package 3, what is the similarity? So it's a square matrix, you can imagine that, right? So it will contain integers which represent the similarity between those two modules. So that's the first. And then you convert the matrix into MDG, is it?
Yes.
MDG is a module dependency graph. So if there exists a dependency, you put an edge between those two packages, and the edge weight will be determined by the amount of similarity between them. So the matrix is actually represented in the form of a graph. So that is the module dependency graph. And then you convert that into, you fetch that MDG into bunch. So that's the third step. And bunch gives you the output of the clusters of packages. So they will be represented in a file format called .e, and that .e file should be converted into an RSF file to be fed into module. So this is the pipeline. So I think this is too much of technicality for you, at least at the moment, but you can just if you don't understand many things, it's not a problem. You can just sit through it and then try to at least minimally understand or follow what's happening. I think it should be okay.
Bunch only does clustering, right? Or does do the reverse engineering?
No, that's simply clustering.
Then what will the reverse engineering?
Yeah, we will do the reverse engineering, and we will directly
so that will
convert
produce
it.
systematic code.
Yeah, we will first take the application. We ourselves will do the reverse engineering. We will come up with the similarity matrix, and then we will take the services of bunch. But had it been a direct Java code, then we can call the bunch directly. But since it's an Android application and we reverse engineer and all those things, we need to come to a certain point where bunch can take over. So that's what.
Okay, so now I will show you all the steps we need to go through using in this
Architecture recovery process.
yeah. Okay, so I will take one example to show you how this works. First, what we need is okay. What we actually need is this 4 files here. I will copy it out. First, we need a dependency matrix. Like just you said, it's a dependency of the packages.
But before that, can you open the labels.txt?
Okay, sure. This is the packages, all the packages we have.
So you are able to relate to this. This is the set of packages that you get from the APK tool, from the Smalley code. I think you should be aware of it already. Okay. So when you reverse engineer the application, these many packages you see. So it should be 11, right? 11 packages, right?
Let me use this tool.
12. Okay, so I think the first 6 are belonging to one batch, and 7 is an individual one. 8 and 9 belong to maybe to one particular subtree, and 10, 11, 12 are independent, right?
Actually, the first
Yeah, yeah,
six
yeah.
are
It's just a prima facie feeling. Like it's not based on any
Oh.
relationship.
okay.
By looking at it, we can say, if you ask me to cluster without any evidence on the relationships,
Yeah.
what we will do is 1 to 6 in one cluster, 7 as singleton cluster, 8 and 9 in one cluster, 10, 11, 12 independent clusters.
Yeah.
So probably you can come up with that kind of a structure, right?
This is a package list.
Yeah, okay.
Label files.
Okay.
And okay, and then we have the dependency matrix, which
Okay,
is
so this is a 12 by 12 matrix.
yes.
Showing pairwise similarity. So can you just elaborate on the first row? What does it say?
Okay. We look at the first row here, and we recall the label files. Here, the first package is called Android Support V4 app, and then here this first line means the dependency, the outgoing dependency of this particular package, the first package, to each other packages. So you see the first number 1096. That means the first package has a dependency on itself.
Of these many units.
Yeah.
And then it's a self dependency. When you imagine it as a graph, you can put the Android Support V4 app as a node and then put an edge to itself and then say the dependency is 1096. And similarly, there is another edge connecting Android V4 app to the second package,
yeah.
and that dependency is 20.
Yes.
So you're able to understand, right? So this is what we have already done. It's not from the bunch. So we need to do it based on some logic, and we came up with our own code for these numbers because these are very significant. Because this will be fetched as an input to the bunch. So if this is wrong, the bunch will produce incorrect clusters. So this is of ultimate importance, and we followed it from another work, and it's not our logic. We just re-implemented the logic given another work. So we came up with the MDG. So you are able to relate to this as a graph, right? It's a matrix, but it can be seen as a graph also. Straightforward. Yeah.
Maybe I will do.
But the 11th row is very interesting. Do you want to say something about it?
Yeah, 11th row, you can see it has no outgoing dependencies. That means it has no dependency on others. And you look at the. Okay, let me do a trick first because this is not quite easy to read.
Okay.
I will use my trick. I put it into an Excel file. Not like this. Okay. This is much better, right? Okay, this is exactly what I do. This is much clearer, right? We can look at the 11th. It has no outgoing dependency, and we look at the column. It has no incoming dependency. That means no packages depends on it.
So but you're also able to notice it, right? It's not a symmetric matrix. It's a square matrix, but it is not symmetric. Like the diagonal has values, and the upper triangle and the lower triangle of the matrices are different. Yes. So that's what he's referring. The rows refer to the outgoing dependencies, the outgoing edges, and the columns represent the incoming edges.
Yes.
Okay.
So you can see the diagonal line actually is all the self dependencies. Most packages have large self dependency.
Okay.
And what we need to do is to convert this into an MDG file. MDG file is for bunch input. And so I will show you what is actually an MDG file.